Good afternoon, everybody. There, that's much better. It's been a long day, hasn't it? So we're almost halfway through Tech Ed. Welcome to Malware Hunting with the sysinternals tools. My name is Mark Rasinovich. Let me get an idea for how many people have seen me present before. How many people have seen me present? Wow, almost lots of people. How many people have not seen me present? Welcome. And let's see, how many people saw me present yesterday? So nobody went to the keynote then? Because I was there. That counted a little. All right. So in any case, let's get started. The mouse will, okay, here we go. Actually, and this statement is really the heart of what this presentation is all about. This came out about 3 months ago in the Cisco fourth quarter 2011 Global Threat Report. You can see during fourth quarter 11, 33% of web malware encountered was zero-day malware, not detectable by traditional signature-based methodologies at the time of encounter. It actually didn't say zero-day there before, but I had them put that in to plug my book. No, I'm just kidding. I'm just kidding. Zero-day malware is malware where there's no antivirus signatures. And how many people have run into malware infestation where the antivirus wasn't aware of what the hell was going on? How many people have cleaned malware off a friend's computer? How about your mom's computer? How about your own computer? All right, what are you guys doing? So the purpose of this talk, therefore, is to learn about some tools and techniques focused on the sysinternals tools, because I happen to think they're okay for this kind of stuff, for analyzing and cleaning malware, and to set expectations about what you're going to take away from here, to really understand and analyze malware, like the kind of analysis you see take place on a sample like Stuxnet. It requires years and years and years of training, requires advanced knowledge of operating system internals and behavior, x86 and x64 assembly language, reverse engineering with static disassemblers and stepping through kernel debuggers. And so obviously I'm not going to be able to train you on that, but the sysinternals tools are used by those same people very frequently. I'm always pleased when there's a report that comes out from antivirus researcher usually at a major company analyzing a piece of malware, and then there's screenshots of sysinternals tools. And Microsoft's own antivirus researchers make heavy use of the tools. What the tools are good for is kind of taking a panoramic look at what the malware is doing. If you have a specimen of malware that you want to understand how it behaves, it's great for understanding the impact of the malware as it inserts itself into the system. It's also great for looking at how might I clean it. So once you get to the point where you want to get it off your system, the tools can help you identify where the malware is, and then how it's operating, and maybe even how it's trying to defend itself from being cleaned off the system. And for antivirus researchers, as well as people cleaning the malware off their system, a lot of times they can generate roadmaps. So if you watch what the malware does on the system while you're cleaning it or trying to clean it, or if you've got something that you can reproducibly create, then you can generate a map by looking at how it impacted the system and how to get it off the system. And this is a controversial point, actually, in some circles, cleaning malware, because, of course, I'm talking here about cleaning malware, but there's people out there that say, don't clean malware. If you're infected with malware, don't bother cleaning it, repave, because you can never be certain that you clean the malware off. And that's a pretty extreme view. I think the point of security is that it's not black and white. It's always risk mitigation. If you understand or feel confident that you have a good lay of the malware, then it might be worth the risk to clean it off. And you've saved yourself the time of having to go rebuild systems and rebuild networks. This is commonly the case. Microsoft incident response, Microsoft's consulting arm that goes out to customers that call them in when they find malware infestations, they often say, we don't want to repave, we want you to clean. There was a large European government organization, multinational government organization last year. They discovered malware sitting on their domain controllers. And they said, we cannot afford to repave our domain. We need you guys to figure out what this malware is doing and clean it off. And so the researchers went in, had a high degree of confidence they understood after they evaluated what was going on, inspected the system, and then cleaned it off. And that was worth the risk for these guys versus the costs of having to deal with downtime, customer dissatisfaction, and all the pain of rebuilding things. So there is a place for cleaning. Now, if you don't really understand what the malware is doing, you might If you don't have a high degree of confidence, of course, that's when repaving might come into play. How many people have used sysinternals antivirus? See, raise your hands. So one person. Yeah, don't use this. I know. So I didn't write it. It's really not very good. It's actually malware, if you hadn't guessed. The really thing that pisses me off, though, is they don't even link to sysinternals. But it kind of that made me laugh when sysinternals antivirus came out. So this is a roadmap for approaching malware. This is a roadmap that I developed 5 or 6 years ago, and it still holds true today. It's basically divided into a phase of reconnaissance, understanding what's going on, different aspects of static analysis of the system and dynamic analysis, and then once you've got a lay of the land, going after and moving into the cleaning phase, which will mean identifying delete malware auto starts, deleting the malware files, and then you see this last step, reboot and repeat. It's like the shampoo things. So lather, rinse, repeat, and that's the case here, and you can probably guess why. It's because a lot of malware, you make your pass through, you think you've found it, you clean off everything you see, you reboot the machine, and woo, it's back. How did that happen? So you go through the process again. What did I miss? And that's oftentimes the case with decent malware, is that you'll have to rinse, lather, repeat cycle on it. Let's start on the first phase now of reconnaissance. How do you identify malware processes? These are tips for common characteristics for malware, and what's really fascinating to me is that this list I came up with again 5 or 6 years ago. Characteristics of images that you'll see that almost always makes a file suspicious. Definitely worth further investigation. Files that have no icon associated with them. There's version information in the image that has no description or company name. They say they're from Microsoft, yet they're unsigned, although now we have Microsoft signed malware out there, apparently. They live in the Windows directory user profile. This is the one thing that changed. They always used to live in the Windows directory, someplace Windows or Windows System 32, but these days now they stick themselves in the user profile. And this is, guess what has forced them to do that? UAC, right? Those are malware developers, or developers like everybody else. Best programming guidance now for Windows is write for standard user, so that's what these guys are doing. They write for standard users, so they've picked up on that. They're packed. I'll talk more about what packed is later. And then if you look inside the images, they've got, of course, funny strings in them. Oftentimes URLs that they're going out to try to reach out to, or IP addresses of command and control servers. When you look at them in action, they'll sometimes have TCP/IP ports open. Again, if it's a botnet serving spam off your machine, if it's communicating with this command and control server, downloading software, it's going to have these ports open. And then finally, if it's hosting inside of the process itself, so not the primary process image, but inside the process hosting DLLs that have some of these same characteristics, that's really what you kind of first look to see if you've got one of those. Because the thing is, when you approach a system, it's much harder to say I'm malware free than it is to say I've got malware. And that's most of the cases start with something suspicious is going on my machine. I see it blasting the network. I see processes coming and going. It's sluggish. Some hint that you might be infected, and that's what causes you to step into this. People ask me, Mark, is your laptop infected right now? And I say, no, I don't even know. I can't tell. I really can't tell. I could follow all this, investigate all those things, but in the end, determining whether you're clean of malware, that's a whole different story. How many people look at processes with Task Manager? See, raise your hands. So that's really like tying your hand behind your back, because there's almost no information in Task Manager that's useful. And actually, I'm running Windows 8, so there's a new Task Manager. Here, there. No, actually, that's not the new Task Manager. Yeah, it could be. Actually, I've made it the new Task Manager here by saying replace Task Manager, so that's why. But I'll get back to that in a second. But this is the old Task Manager from Windows 7 and previously. The kind of interesting thing about this Task Manager is, first of all, no icon. I mean, digging into some of those tips that I had on the previous slide, you just can't do it with this. It won't even tell you the company name. It'll tell you the description, but you can't see the manufacturer of it. And then you can add a column as a Windows 7 that will give you the path to it. But it's really not good for that purpose. So the tool that I recommend using and that I'm going to focus on here is Process Explorer. Some people call it Super Task Manager because it does a lot more than Task Manager was designed to do. I really wanted to make it a heavy-duty, hardcore, every little detail, technical tidbit most people aren't interested in, it's going to be in here, and actually used it in Windows internals training classes to show how the system works underneath to a level that most IT pros don't care about. But it's primarily got a lot of features that are really good for troubleshooting, like DLL versioning problems, finding an open handle, looking at hung processes. What I'm going to do here in the next few slides is take you through primarily its malware-oriented features, its malware hunting capabilities. So the first thing we'll take a look at is I'm still getting used to this new thing, because you used to just be able to get the taskbar by saying window key, and now you can't. So, arg. This is my first time to present off of Windows 8. So it's a learning experience for, I think, all of us. Now, how do I get to my taskbar? All right, so I'll just do that. Oh, I could have just launched Task Manager and I got it. Anyway, so let's get back to this. This is a process tree and Process Explorer. What this shows you is the parent-child relationship between processes. If I look, that will tell me some information a lot of times about processes, especially when I'm going malware hunting. In this case right here, I'm focused on a process called services.exe. Let me actually launch with admin rights. And services.exe is the service control manager. It says services and controller app here. Any child of this process is going to be hosting Windows services. So that is one hint of the process tree is if this guy is in charge of Windows services, it's natural to expect that child processes are going to be hosting Windows services. If I scroll down here, I can see explorer.exe. Explorer.exe being my shell, and you can see everything I've launched since I've logged in is going to be underneath that unless the parent process is terminated, because Process Explorer can't know who the parent is or show the parent if it's gone. And you'll see processes like that left justified, which is why Explorer is left justified. In fact, if you watch the process creation from the boot of Windows, it'll form a perfect tree with everybody having a parent all the way back to the system as the root. That once you take a look at it like this, you're going to see orphans like this, poor old Explorer. Does anybody know who Explorer's parent is that abandoned it in its youth? No, not WinLogon. User init, yep, good second guess, yeah. Would have been better if you got it the first time, but still give you credit, partial credit. Now, the other thing that you see is version information that you didn't see in Task Manager. It'll show you both the description and the company name. If you hover over the tooltip over image, it'll show you the command line as well and the full path to the executable image. The command line, of course, can be very interesting, and I'll talk about hosted processes in a second that will give you information about processes components that are hosted within a process, and the command line can help you find out what's going on there. One of the characteristics that I find particularly useful and was actually more useful when malware was very loud and noisy back 5 or 6 years ago, because it was a different era then. We had adware and spamware and crapware that would just fill your screen with dialog boxes and pop-ups and take you to websites. And back then, you get one of these pop-ups and it was like, which process is putting that pop-up up? Well, Process Explorer will show you, just by hovering this bullseye over a process, over a window, which process owns it. And you can see in this case that obviously is Explorer owning that. So that can be useful there. These days, most malware is pretty obvious about where it's coming from, either that or it's completely silent, like a botnet. And so it has no windows for you to even try that on. Search online is a feature that can be useful for hunting down malware or finding out about a process that you don't know anything about. For example, if I say, what is this FVE notify, I can say search online, and that will perform a search with your favorite search engine. So here's FEE notify, and you can see the results. And this, unfortunately, this is really irritating because most of the time these things are basically malware sites themselves with the amount of crap that they throw in your face with not even telling you anything about this. Like, well, I already know all of this information. Like, really, what is it? So not very useful, I found. And a lot of times you've got to search down through the links to eventually find something that is relevant. But that feature is actually becoming almost obsolete now these days when it comes to hunting down malware. The reason why, as you'll see in some of these examples, is that most malware now generates random names for its executables. So you perform a search on it, you're the only one that got that random name, so of course nobody else is going to have talked about it. But it's worth knowing for fixed name executables. I really wish I knew. Does anybody know how to get from PowerPoint back to the taskbar? Does anybody? Windows 8 experts out there? You're all using Windows 8, aren't you? Yeah. Well, Alt-Tab doesn't show you the taskbar. Just Alt-T, somebody said? No. Win-T? Oh, Win-T. Cool. All right. There you go. By the way, there's another tip I've got for you, and that's Window key X. There's the start menu. So how many people know about Window key X? So, okay, there you go. That's your Windows 8 tip of the day. So one of the other features of Process Explorer is refresh highlighting. For processes that come and go, you can see them highlighted in green and blue. Now, let me launch a new process here from a launch command prompt. And you can see, I just press pause, that those two processes just highlighted in green. In fact, that's what happens when you launch a command prompt. There's a host process that's actually listening to Windows message. And then there's a command.exe child process that is actually going and executing the commands that you enter in the command prompt. If I refresh, the green highlighting will go away. You can see search filter woke up. Actually, two processes, one died and one reincarnated in its place. And if I close this, I get the red. This is all well and good and can give you a coarse-grained look at processes coming and going. The problem with this, though, is short-lived processes will be missed because Process Explorer is refreshing at the rate you specify. Half a second is the lowest. And so if a process is born within the refresh period and dies, you're not going to see it show up with the highlighting color. So we're going to see how to track short-lived processes in a few minutes. I mentioned the process type highlights, the tooltips. Now let's talk about the colors. If you go take a look at the display, you can see that certain processes have certain colors. Does anybody know what the pink means? It's a girl process. That's what it means. No, I'm just kidding. And it means that it's hosting a Windows service. A blue process is one that's running in the same security context as Process Explorer. So this is another way of saying these are my processes, the blue ones. White is, of course, anything that doesn't match that, like it's a system process or it's a process running in a different user account. And then you can see some purplish dark blue colors here, and you can also see this cyan color. This cyan color says that it's actually a Metro app. So this is actually flagged as Metro for some reason. I haven't dug into why Explorer is flagged as Metro. But if I launch something in Metro, it would also show up with that color highlight. And then I'll come back and talk about this highlight here in a second. So tooltips. I mentioned tooltips. They show things that are running inside of processes. And it's very common to have malware that I forgot my window key, my new window key T trick. But it's very common to have processes that are hiding inside of host processes. I've seen malware that hides inside of run DLL32, which is a host process for control panel applets. Here's the date time applet. If I take the bullseye and hover and target it, you can see that it's this process right here, which is run DLL32. And you can see here, there's the target of that run DLL32, timedate.cpl. And here's the run target information right here. So Process Explorer reaches into the target. It understands run DLL32. It understands DCOM host and several other hosting processes, including IE, and we'll show you what's running inside of them, like that, what they're hosting. So that can be useful too if malware is hiding inside of run DLL32. And the tooltip for service processes shows hosted services. I'll talk about that. How many people have downloaded Process Explorer in the last week? Anybody? So you might have seen a couple of new features I introduced last week. One of them is auto start locations. Auto start locations you can add as a column here. If I go and say auto start location, what this has done is scanned auto start locations in the system and will tell us where things have been registered to auto execute. This doesn't necessarily mean that these images, these processes were launched this way, but it means that this process image is registered in these locations. So it could have been, but it's a good way to see how things might get automatically executed. You can see that that's why Explorer gets launched automatically, because it's the HK local machine software shell. And we can see why Zoom It launches automatically when I log in, because I put it in my startup folder as a shortcut. Let's dig in now on these two processes, which are kind of sticking out like a little bit from the others. I mentioned this dark blue is packed. Packed means that it's compressed or encrypted, and this is extremely common for malware to be compressed or encrypted. Process Explorer has a few heuristics built into it to try to detect compressed and encrypted executables. Some of the heuristics are basically just looking at the header and seeing if there's a signature for a common compressor or packer, and other ones are looking inside the image to see if certain characteristics of the executable look like it's compressed or encrypted. So we've got two potentially packed images here, and we can see that they say that they're from Microsoft. They've got icons that look like they're system icons. In fact, if I find WinLogon, where's WinLogon? Well, WinLogon's not running right now. But if we saw WinLogon, it's got the same exact, oh, actually, there it is. I don't know why we're not seeing an icon, unless it was removed in Windows 8. Well, so it has the exact icon of the old WinLogon in Windows 7. We can see that it's calls itself Windows Host Support Service. It's from Microsoft, and here's where it starts automatically. We're going to come back to that in a minute. But this is a suspicious process just because it looks like it's from Microsoft, and yet it's got this packed characteristic on it. The other feature that I introduced is process timeline. You can add that over in the process performance here. And this is also potentially useful for troubleshooting malware, because processes, some of the system processes have natural lifetimes, like they start when the system boots very early. Here's, of course, the first processes in the system. And then you can see ones that have launched later. So a system process that should start early has a name that you recognize, but starts later, probably malware hiding inside that system process. If you want to drill in a little more to look at detailed process information, of course, the process properties, let's drill into these guys and look at the image properties for this. So we see the image is probably packed. We see the build time here. So actually that's suspicious, because this is an image that was built really recently. In fact, that is today, actually. So something built today that's part of Windows, either it came down as a Windows update, as a hotfix, or it's something that's not supposed to be there. It's sitting in the Windows directory. Here's its command line. Here's its current working directory. And then the auto start location is here. And these are two other features that I added, is ability to jump to those locations to look at those files. You can see the parent process, the time that it started, which again is the process timeline, and then there's security-related information about the process, whether it's got DEP or ASLR. So this process so far, we don't see anything more suspicious other than the fact that it's packed. It's where we'd expect a Windows executable to go. We need to drill in some more to find out more about it. And that's where image verification comes into play. Image verification is checking the digital signature on files. Most legitimate software now, almost all legitimate software now for Windows, and for Windows 8 Metro, all legitimate software will be digitally signed. And that means that there's a tamper-proof seal on the image that says this was produced by this company that's got this digital certificate. Well, mostly tamper-proof. In any case, all Microsoft code is signed, and unless you hack a terminal server, licensing server, and figure out how to create MD5 collisions. By the way, this is a joke. I'm referring to what happened a couple weeks ago, where Flame was discovered, the Flame virus, which I'll talk more about later, was discovered to have been using a certificate to make it software or look like it was signed by Microsoft. And they hadn't actually stolen our certificate, but they'd figured out how to sign files with collision, take valid signatures and create images that match them so that it looked like they were signed by Microsoft. But this is still a very useful feature despite various problems with signature verification. I'll talk more about another one later. You can check for signature verification manually by saying verify here on the process properties. And we see that this one, that's a red flag right there, unable to verify. So this is almost certainly malware at this point because says it's from Microsoft, and yet this has no valid Microsoft signature on it. If we took a look at Explorer, for example, and said verify, we'd see that it is verified as being from Microsoft. But going and manually checking like that is tedious. What I'd normally do is I say put on the verified signer column and then go to options and say verify all image signatures. And now what Process Explorer does, whenever it sees a new image, it'll go off and start to verify it, and then I can sort and find the ones that failed verification. And in this case, we can see that the ones that failed verification are those suspicious ones, as well as my test versions of ZoomIt that aren't digitally signed with the official Microsoft or sysinternals certificate. There's I mentioned in the troubleshooting phases to disconnect from the network is the first step. And the reason that I say that is in the original days of anti-malware, this is when you'd have software that would just be pulling more malware down off the network. And I actually ran into situations where I'd be cleaning the malware off and not being able to keep up with the new malware coming down onto the system. So I'd have to disconnect from the network just for that. But it also has other benefits too. You stop the malware from exfiltrating data if it's doing that. You stop it from talking to its command and control server and downloading updates, and you stop it from going and probing your network for new targets. So that's why I have this recommendation to disconnect. It has the downside, though, here, that the certificate revocation lists are inaccessible. And that means that if something was signed with a screwy cert, like the one on Flame, and you didn't get the patch locally applied with the revocation in it, that the system's going to go out to servers on the internet and ask if the cert's valid. And if you've disconnected, of course, it's not going to be able to, and the cert will still look as legitimate. So that's the downside of disconnecting from the network. If you've got a suspicious file, therefore, I recommend you take it off the system and use this tool, SIGCheck. SIGCheck, another sysinternals tool. This one, you can point at a file and have it check for digital signatures. So, for example, if I go into Windows System 32, I can say SIGCheck, or Windows SIGCheck, and I can say -E, -S is what I'd normally do, -U, and what this command will do is a recursive subdirectory scan of the directory that we pointed at, here it's just the Windows directory. Look at only executable files, don't look at data files. Now, this doesn't use file extensions like certain antivirus is just recently been discovered to only consider files with certain extensions as executable. This actually looks at the portable executable header to see if it actually is a Windows executable, regardless of the extension. It does a direct, this is recurse, and this is only show me the unsigned stuff. And when I press enter, this is going to eventually find WinHost, and there it is, the first one. We can see there's .NET assemblies that were ngenned or JITted here or ngenned in the cache, whatever the .NET guys do with their stuff. You know, I'm mostly a native guy myself. But you can see that this is actually a great place to hide malware, is down here in this part of the system. And I haven't heard of anybody doing it, but I wouldn't be surprised if we see it at some point because it's a great place for executables to be there, be unsigned, and be indistinguishable from software that's supposed to be signed. So that's SIGCheck. And then list DLLs is a command line tool. I'm not going to show it to you, but you can use that to scan the DLLs of a process. I'll talk about DLLs in a second. But what we were just looking at in Process Explorer was only the processes themselves. Now, let's say that you want to do a little more digging to see what a process is all about. You still are unsure. Is it malware or is it not? Or is it legitimate? The next step is to look inside the process image to see if you see any more hints. Many images, you can check the on-disk version of the file to see if it's got any printable strings. Sorry, I keep doing that. Old habits die hard. But if I use the strings command on Explorer, for example, I'll see a bunch of printable strings come out. And eventually I'll see error messages and registry keys and other things that are stored in Explorer. So that's one way to look for printable strings. But the problem, as I mentioned, is that a lot of malware is packed now or encrypted. What that means is that it's on disk in obfuscated form. When it launches into memory, it has an unpacker that will unravel the on-disk stuff into memory and then start executing that. So you can't use a tool like strings to look at it statically. You need to actually look at the active image. And you can, of course, do that with Process Explorer. So these two Win hosts down here, let's take a look inside of them. I'll go to the Strings tab. And this is packed. So here we're just going to see the stuff that's not been encrypted. In fact, here's why it shows up as packed, is that signature right here. This is the most common packer used. It's like 15 years old, and it's evolved over time, and many hackers take that, this public, open source, well, it's just free source out there on the web, and people take it and customize it. But by default, it's got that signature. So if we click on memory, this will show us the in-memory strings. And what you're supposed to do, again, like I said, is look for suspicious URLs. And there's one right there. So this guy looks pretty suspicious at this point. If we weren't convinced already by the fact that it's not signed and from Microsoft. So that's looking at something with strings. Last, the DLL view I mentioned. Looking at the DLLs loaded into a process. Malware a lot of times hides as DLLs. Injected into legitimate processes. You've already seen run DLL 32. Service host processes also host DLLs as their service components. They typically load via auto starts. So the way that you look at these is inside the DLL view. Let's just take a look at the DLL view for this process. I'm going to do Control D to open it up. It's going to do a scan. I've got automatic signature verification turned on, so if I add the verified signer column here, I'm going to get the same basic look, with the only unable to verify being that WinHost executable, which also shows up in the DLL list. And then you can also do this, is look at the strings of that particular image inside the process. So it doesn't have to be the primary process image. You can look at the DLL list and look at the strings for that DLL as they're loaded into memory as well. Now, how about terminating processes? Because that's the end of the first phase. So I've done recon. I've figured out which processes are the suspicious ones. Now I need to get them out of the way before I move on to the next phase of cleaning. Why do I need to get them out of the way? Oftentimes, malware is pretty robust, and it will sit there and monitor its auto start locations, for example, because that's one of the things you need to go clean. So when it sees you delete the startup link, it'll sit there and put it right back. It sees you delete the run key, it'll put it right back. So you need to get out of the way. But don't kill them. Don't kill these guys. It's just not humane. It's actually much better to do what? Suspend them. Why do you suspend them? It's actually not because it's humane. It's because of this factor right here. We see two WinHosts right there. I delete one. What just happened? Anybody see that? Yeah, it's the buddy system. These guys are looking out for each other, and so I can't kill them together. One guy sees his fallen comrade, revives him, vice versa. This is also very common, and I think that actually the commercial software business should probably learn something from these guys. But if I suspend them, and I put them into a deep sleep, and now they're asleep, and they're still think they're watching each other, but they went to sleep at basically on guard, and now I can take them out. Boom. And they're gone. Once you've figured out how to take care of those suspicious processes, now let's clean the auto starts off the system. How many people use msconfig? I hope my tone of voice didn't give away my feelings about this tool. But it's gotten a lot better in Windows 8. Has anybody played with it? Now check this out whenever it comes up. So we go to the startup. Man, that's awesome. Well, okay, so open Task Manager. Oops, that is Task Manager. So here we go. This is now what you see. So it's very clear that Windows 8 is aimed at simplifying people's lives, not polluting them with stuff that they just don't want to know about, like the malware that's lurking in certain places. So So it's actually, the situation's gotten prettier, but a little worse when it comes to using built-in Windows tools to find the auto starts. So of course, I'm going to show you auto runs. How many people have used auto runs to look? So quite a few of you. How many people have not used auto runs? All right, you can leave. No, just kidding. So let's go back to auto runs and take a quick tour of it. So auto runs will scan all of the places, I mean dozens and dozens of places that have been collected by me, Bryce before he retired and went off into the sunset, and other people that have sent us places that we've missed, to I think be the most comprehensive collection of auto start locations of any tool out there. And it's, like I said, dozens and dozens of entries that it scans. If you scroll through, these are all the things that are registered. It's a pretty daunting list. So what I'm going to do is set a filter, which you want to set when you're hunting malware, which is to hide Microsoft entries and verified code signatures. And now we're going to boil down to just the things that are suspicious or unsigned. So red processes are unsigned, yellow, missing images. And you can see that these images right here that are missing are sitting off on the Microsoft corporate network. It's part of group policy scripts that run when we log in. I'm not connected, so that's why auto runs can't find them. But of course, our old friend WinHost shows up here. If you click here, WinHost, you'll see some information about it. Here's that timestamp again that's suspicious. And what you can also do from here is you can search online for it, like you could in Process Explorer. You can look at the properties in Explorer for it, if you'd like. But also, for when it comes to cleaning, you can do jump to entry or jump to folder. If you jump to folder, then you'll find the place where that image is actually stored. And if you jump to entry, you need to be admin to launch regedit. But if you do a jump to entry, then auto runs hypnotizes regedit and under its command navigates you down to the place where that's configured to launch. And now what we can do is clean it off the system. It's got some other characteristics too that are worth mentioning. You can look at other user profiles as well. Here in the user column, you can look at the system account, local service, network service. I've got another account here, Mark. I could go scan its per user startup settings. You can also scan offline systems. So if you've got a VHD you've mounted, if of a system that's infected, you can point it at the Windows directory in the user profile you want to scan, and it'll go do that offline as well. And then there's Auto Run C down here at the bottom. It's a command line utility. I'm not going to bother showing you, but this is a good way to just do automated scanning of your system's auto start locations. Do an Auto Run C, you can have it scan and just report the unsigned executables, for example. And that way you just have a regular task with alerts maybe that come back when Auto Run spots something on your network. When you delete an auto start location, remember to press F5 because this is a case of a lurking piece of malware, still active, repairing itself that you might have missed. So do an F5 and make sure that your delete really stuck. Sometimes it doesn't. And if it doesn't, well, that means that you missed on your recon phase. You go back, lather, rinse, repeat. Let's say that you get back to this point and try it again and you still comes back. Obviously, there's something going on that you're not able to catch using the analysis that we've just talked about. So how do you find who's putting it back? That's where you turn to tracing malware activity with Process Monitor. How many people have used Process Monitor? So quite a few of you. Process Monitor is like the old Regmon and FileMon combined with a whole bunch of other features added on top. If I launch Process Monitor here, and let's just take a very quick look at what Process Monitor will show us. And Process Monitor shows us all, like I said, file system registry activity. If you use FileMon or Regmon, it looks very familiar, except you get tooltips right here. Tooltips that will show you the path to the executable, as well as the version information that we talked about before, the operation, the path, the result of that path, and then if it was a successful operation or there was input parameters, it will show you the data that came in. So here's, for example, an operation of a create file where you can see the desired access, the disposition, and so on. Process Monitor has a few ways of filtering and a few ways of looking at more advanced properties. Let's take a look at some of the filtering. There's quick filters up here if I just want to see file system activity. There's filters here, what I call quick filters, if I just want to see particular operations like this query standard information file, and in fact I want to see just queries on this or exclude queries on that. I accidentally hit the wrong one. Now I'm looking at everything except for queries to that path that I was on. So that's a great way to start drilling down to what you want to have access to. The things shown in the display are a subset of the information for a particular event. If you open the event properties, you can see class, operation, path, duration for performance, and then here's the results that we saw. Here's information about the process, and this can be useful for looking at some of the same things we saw in Process Explorer. And then if we look at the stack, this will tell us sometimes when malware was responsible. Because in most cases, if it's a legitimate Windows executable we're looking at, a process like a system process, you will see a valid DLL for every line in that trace. Because Microsoft executables use standard calling conventions that make it easy for Process Monitor to walk the stack and see what happened. If you see an unknown in there, sign of potential malware, sign of injection of malware into a system process. So that's something to look out for as well. And we're actually going to see some examples of that later. There's more advanced filtering too. And now this is a feature that a lot of people don't know about, but I find very cool. Is let's say that I've applied filters, but I've lost my context because I've removed so much. And I want it back, but I want to go, I do value the filter that I just set. So how do I disable the filter? I can just come over here and say, I don't want that filter to be active, the one that just filters query standard information file. And now I can say apply, and now I've got back everything. And if I just want to put my filter, of course, I just open that filter dialog and recheck it and apply. So it's a good way to mess with filters. The most interesting filter for me for understanding what malware is doing when it infects a system is category is right. What this does is just show the modifications that are taking place on the system. I just did a Control-R to reset the filters to their defaults, and I'm going to say category is right. And now we're just seeing attempted changes and successful changes to the system. So Explorer is doing things like trying to create files for some reason. If we look at the stack, it'll tell us why, probably. Because we got symbols, force image present. So you can see the impact because you'll see malware sticking itself in various registry keys and dropping files on disk. And like I said, we're going to see examples of that shortly. So that's a quick tour of Process Monitor's list view. Let's take a look at another feature that is really cool. I think one of the most powerful features of Process Monitor. That is the process tree. And remember I told you that how do you see short-lived processes? This is a great way to see them. Because anything in gray is a process that's terminated since Process Monitor started monitoring. So if I had a very short-lived process, like let's make a short-lived process. I'm going to do an IP config. That's an extremely short-lived process, probably wouldn't even show up in Process Monitor, and yet we're going to see it. Where's oh, I turned off filtering, monitoring. Let's try that again. IP config, and we're going to see it show up as a child of command.exe. Where is it? Up. There it is. IP config. Now, Process Monitor is populating icons in the background, which is why we don't see one yet. It will pop. If we launch this again, we'd see the icon. But that's a very short-lived process. You can see under a second it lived, and we can still spot it. So it's a great way to see more than what Process Monitor Explorer can show you in terms of activity, process-related activity on the system. Okay, so that's the setup. We've just been playing with my little piece of demo malware, which is all pretty fun and cool. But let's get on to some real stuff. This one is a case that was brought to me by a friend. Let me get this VM ready here for us. So this will take a second to apply. But this case started with the way many of your cases start, which is a friend asked another friend, hey, can you take a look at my laptop? It's running slowly. It boots really slowly, and it's not Windows Vista. So it's actually not a fair joke. Windows Vista is pretty decent. But what's more concerning about this is it boots slowly, and so the person thought maybe it's infected. He tried to run Microsoft Security Essentials, and Microsoft Security Essentials would get partway through a scan and just hang, would never finish. So that's kind of suspicious. The user also looked at Task Manager. Of course, you can't see anything there anyway, so nothing jumped out there. They tried running sysinternals tools. So this is when it was given to their other friend who knew about how to use sysinternals tools to look at some of this stuff. They tried to run the sysinternals tools. And every time they ran one of the tools, it would flash and disappear. Process monitor, flash, disappear. Auto runs, flash, disappear. They were saying, it's got to be malware now, messing with this. But how is the malware detecting it? So they tried an experiment. They created a file called Process Explorer and opened it in Notepad. And Notepad launches, poof, disappears. So that's a clue for how this malware is trying to detect the presence of security tools like sysinternals. So they were a little flummoxed at this point. Said, I don't know how to use the troubleshooting tools I know to track this down. They go to sysinternals utility index, and they just started literally going one by one and saying, does that tool, have I heard of that? Maybe that's useful. They get distracted for a few hours because they're finding tools they've never seen before that are really cool. Just kidding. Then they get to the Ds, and they get to a tool called desktops. Does anybody use desktops? Yeah, so desktops is a multi-desktop utility. I've got it running here in this VM. If I do, what it does is create multiple virtual desktops. For example, I can say, I want a second desktop, and here I'm on a second desktop. I can launch things and browse to websites, and then I can switch back to the first desktop. I can browse back to the web, to websites, and then when my boss comes, I can flip back. So that's one of the cool uses of desktops. Let me get the next demo ready here. So what the person did was said, oh, desktops, maybe I'll try that. And so sure enough, they went and tried to run sysinternals utilities on the second desktop, and they actually worked. And the reason why was kind of the clue given by the fact that Notepad would close, because this malware is obviously looking at Windows titles for certain keywords, like sysinternals probably. And so anything with any window with that, it's going to kill the process that's hosting it. He's running on a separate desktop, though, and windows are only visible on the desktop that you perform the window enumeration on. So the malware is on the first desktop, doesn't see the sysinternals tools on the second desktop, and obviously then doesn't know to close them. So he's able to do his analysis from there. So he runs Process Explorer, doesn't see anything suspicious. Then he runs Process Monitor. Let's see what Process Monitor showed him. And what he saw was this. WinLogon, the legitimate WinLogon sitting in Windows System 32, doing repeated queries of this key right here. Microsoft Windows NT current version WinLogon notify. And does that DLL name look suspicious? Or that location look suspicious? ACDC, I guess I like ACDC, but maybe the malware author does too, but it does look a little suspicious. And if we look at what it's querying, it's actually a location of a DLL on disk with that same name. So definitely this looks like the problem. So what's he do with this information? He jumps to the registry. You can do that in Process Explorer, Process Monitor, like we could do in Process Explorer and like we could do in auto runs as well. I can right click and say jump to, and that will jump to the registry location. Now this won't work here because I don't have that key there. But what he did is jumped, and he saw this registration for WinLogon notification DLL right there. Obviously the bad one. So he tried deleting the key. It comes right back. So the malware's sitting inside of WinLogon, obviously, and it's protecting its registry key. So he said, how do I get rid of it? Well, now that I can launch programs on second desktops, and I can know where the DLL is that's bad. Let me see if MSE will work. So he goes back to the second desktop, launches Microsoft Security Essentials, and points it just at that DLL. And sure enough, there's the result. It's Win32 SwimNag, if anybody hadn't picked that up. And so it said, hey, I'm going to clean it off for you. And sure enough, cleans it off, system went back to normal. Yay. All right, let's take a look at another one. This one I'm going to show you live. And showing you stuff live is always a little tricky because malware is pretty unpredictable when you've got it live and in the wild. I just hope it doesn't break out, so everybody turn off your laptops. Now this one is called fake sysdef, and it's a kind of scareware. Scareware is, of course, so popular these days that there's a special section in the Microsoft Security Intelligence Report that we release once a quarter. This is the graph of the current threats charted over time. This is fourth quarter of last year, and you can see fake sysdef has been around for a while, but it's making a big resurgence here. Has anybody run into this one? Anybody know? You have? You have? Really? Yeah, okay, cool. So this is going to look familiar to you. Hope I don't spoil it. Now fake sysdef is tough for me to activate too because it's got a few characteristics that are really obnoxious. First, when you launch it, it takes 10 minutes to activate. So should I do a demo and then launch this here and then we can talk about, how the conference is going for 10 minutes? No. So I'll jump right to here after it's basically executed. And you can see that lots of scary crap is showing up on the screen. This is going to freak out anybody because this looks pretty legitimate. Error reading drive C, scan and repair, system hard disk error, write command failed. It's like, oh crap, this is really bad. So what do? Scan and repair, of course. So let's see what happens when we scan and repair. Well, there we go. Oh, it's a smart check utility. Cool, I didn't know Windows had this. And it's going to recover my data. It's finding all sorts of things. In fact, this kind of shows that these guys know a little bit about what they're doing. Is because those errors down there, hex 24, NTFS file system, those are actually blue screen stop codes. So these aren't just made up things. Now, you can't have a blue screen stop code on your disk. So that's where maybe they didn't realize that. But thank goodness checking read-write. The read-write is OK. That's got me feeling better. So anyway, you can see now actually what just happened is the malware got this one in particular, it's got anti-debugging stuff in it. And so this is what happens when it starts to detect something funny on the system, it'll disappear. Now, I haven't figured out exactly what it is. I believe it's doing some sysinternals check because I actually have running on a second desktop some sysinternals tools that have captured what's going on while that guy was running. And unfortunately, that guy didn't do his full, well, yeah, he did. Look at what happened. Does that look like your start menu? It's like, where did everything go? So what this guy did to really make you scared is actually go and screw with your hard disk. It actually messes with the system so that it gets rid of or hides things so that when you go look, you're like, wow, the system really is hosed. And then the only way to get it back, presumably, is to go pay that dialogue, if it hadn't gotten scared and run away, pay it money to bring things back. And it actually might be scared because there's no network connection here or something like that. But let's go to category is right and see what this guy did. Category is right. And by the way, I'm running on a second desktop, but I also, if you take a close look, I had to rename Process Monitor Procmon1. So because it actually looks for Windows named with sysinternals on the current desktop, it also looks for executables that match certain sysinternals tools. So Procmon, if I just run that, wouldn't have worked. I had to run Procmon1. And this is actually going to take a while. So actually, I think that I've got this captured here, or we can come back to it. Window key T, WinWebSeg. So actually, what this did the last time I ran it, successfully is I capture, actually that's SICBot, that's the wrong one. I misnamed that one. That's a different piece of malware that we're going to see in a minute. What I'm going to do, it always varies how long this is going to take based on what VMs I've just started, and also trusted installer happened to get in my way at the same time. But let's do this. Let's take a look and see if we can just filter for WinWebSec while it was running. And there it is. And actually, if we look at what it did, it's launched a bunch of attrib commands. What are those attrib commands doing? Let's zoom in and see one of them, because that's the key to us fixing this system. Right there. So actually it's hiding everything in my profiles. Not only that, but it's also, Process Monitor will show us if that category write finished, that it's taken everything in the program files directory and moved it into my profile as well, into a randomly named subdirectory. So that's, if you reverse those operations right there, and I've done this, of all these attribs, you'll get your system back, and then reverse what Process Monitor showed you of the program files, and then finally clean up the run key that it creates so that the next time you reboot, it puts itself back, you'll get your system back into working order. And by the way, this is a boot log, so you can see the full process list here. So that's WinWebSec, again, one of the most notorious ones. We were able to pretty much figure out how it worked just with a few minutes with Process Monitor. Here's another one, the case of the strange reboots that somebody had. This is all the classic signs. Laptop would reboot immediately after connecting to a wireless network. Then it would boot into safe mode, then boot back into normal mode, just automatically, boom, boom. So booting to safe mode intentionally, the system would just log the user off. So this system is really hosed. They tried to run MSE. You can see the results of that. A lot of malware these days disables anti-malware, and so you can't run it at all. They ran Process Explorer, and take a look at this display. All of the common characteristics that I mentioned. So system files or system sounding files, service host driver.exe, no description, no company name, and they're packed. And there's a lot of them. So obviously he can't go and kill them all. And it's got open TCP/IP connections as well. So what he did was ran auto runs. Again, saw that it had registered itself all over the place. So this guy is pretty hardcore about keeping itself preserved on the system. If you go delete the auto start keys, it'll put him back. If you kill the processes, it'll put him back. So what did he do, of course? He just went and suspended them all. All of the ones that looked suspicious, blatantly suspicious, he just suspended them and then went and killed them one by one. At that point, he could connect to the network with no restart, so he could get the latest signatures from MSE and then do a scan, and this is what the system had on it. So just a few minutes with Process Explorer, and it got past a case that anti-malware was not able to deal with at that point. Actually not able to deal with mostly because he couldn't even connect to the network. So let's take a look at another one. This is SICBot. Actually, I think that's a kind of a clever name. This is one SICBot we're talking about here. And actually, I don't know why it's called SICBot. And actually, nobody knows why these things get the names they do. It's just some random guy that's doing his anti-malware research at 3 in the morning and sees some strings here and there and glues them together, and then that sticks. But this piece of malware right here is a very notorious botnet that made its rounds last year. And I've got IE down here, pointing at the SICBot, SICBot description. So this is the more common kind of thing. This is a backdoor Trojan that allows attackers unauthorized access and control of an affected computer. After it's infected, the Trojan connects to a specific remote server to receive commands from attackers. So let's take a look at what this one does in action by going over here to SICBot. And this will take a second to apply, and I'll connect. And then we'll just have enough time for our closer, which is Stuxnet. But let's take a quick look at SICBot. Because this one's got some interesting characteristics as well, but ones that have matched what I've talked about in terms of malware trying to protect itself. So view. I've got this one ready to launch. Let's see what SICBot does. And because it's a botnet, we're not going to see a whole lot. Let's do category is right. And then let's go take a look at what we see in Process Explorer. And here's SICBot. Again, we've got the common characteristics here. It has no icon, so a generic icon, so it didn't even try to steal one. It's called SICBot, which gives it away right there. No, I'm just kidding. I named it that. This is the malware sample. It's got no description or company name. It doesn't show up as packed here, although it really is packed. This is a case where I don't have the heuristics that detect that this is packed in Process Explorer, so I need to go back and figure out how this thing is encrypting itself, and maybe I can figure out a way to figure it out. If we sit here for a while, what's going to happen is you saw the child process terminate. Periodically, it'll create a child process and then respawn it. It also creates a run key so that if I reboot, it comes back. And it's made a copy of itself in a place that it's registered to auto start. And I can see that by taking a look at the places where it's dropping the file. You can see it's dropping a file right here into my user profile. You can see it's 55dd.exe. And then if I search for /run, there it is. It's putting itself in HQ current user software Microsoft Windows current version run 5dd.exe, and that's the path to that's executable. So this is a classic case too of malware that's designed for standard user. I ran that unelevated. It's sticking itself in the run key, and this is a very prolific piece of malware that's made its rounds. We've just learned enough to clean it. Basically, all I have to do, and this doesn't do any protection, is I do jump to, delete this thing, and then I can go delete the executable. I can kill the process in Process Explorer, and the thing is off the system. There's an interesting lesson there with how easy it is actually to clean that thing off, which I'll get to in the end. Now, let me get this next one ready while I introduce it. Whoops. And that is this one right here. Has anybody seen me demo this? Just to one person. So what I'm about to demo is a piece of malware called Stuxnet, which I bet a lot of people in here have heard of. Has anybody not heard of Stuxnet? Anybody? Really? Oh, one person. Okay, good. So then I'll tell you about it. Actually, this is kind of funny too. This is a Stuxnet joke up here for Clippy. But Stuxnet was discovered about 2 years ago, almost exactly 2 years ago. It had been spreading for at least a year, quietly, stealthily. It exploited 4 zero-day vulnerabilities. Vulnerabilities in Windows that nobody had seen or known about before they discovered Stuxnet and analyzed it and found that it was using these things. One is a print spooler vulnerability where it could elevate to admin, well, actually to remote code execute on different systems by injecting malware into the print spooler of another machine. This was one way that it spread. The primary way that it spread, though, is the second vulnerability, a shell link parsing problem, so that if a malformed shortcut file is viewed in Explorer, it would cause code to execute in Explorer, and that's how Stuxnet would jump from the file into Explorer and then start to infect the system from there. People believe that it spread primarily via USB keys in this manner. And then once it's on a system, it exploited 2 zero-day vulnerabilities, depending on whether it's XP or Vista, to gain admin rights. If it's on XP, it uses a Win32k kernel vulnerability to get from standard user rights to admin rights, and if it's on Vista, it uses a task scheduler bug that allows unprivileged processes to modify tasks to run in the system account, so it could create a systemic task for itself to infect the system with admin rights. very clever and ingenious ways of infecting a system and elevating privilege. Now, obviously meant for high security environments where people are running pretty rigorously as standard user. That's what it's targeted at. It had drivers that were signed by legitimate independent hardware vendors, Realtek and Micron. So when this was discovered, there's drivers that it installed that were malicious. These cases, they actually stole the signing certificates from those companies. They happened to be across from each other in an office park in Taiwan. And so somebody there got their certificates and used them to sign. Now, for a couple of years, it was analyzed. It was spreading through the Middle East, primarily in Iran, and all of the other signs, especially the fact that it also had a rootkit in it, not for Windows, but aimed at Siemens Step 7 SCADA controllers. These are the kind of programmable logical controllers that control factory automation. In this case, this particular one used by the Iranian nuclear program to control the centrifuges that spin uranium to enrich it to create fuel that could be used to create a nuclear weapon. So all of the clues put together, plus some other telltale signs, and people believe this thing is actually after Iran's nuclear program. Who could be behind that? Well, I think it's kind of obvious who people were pointing the finger at, US and Israel. Anybody see the New York Times article about 2 weeks ago? So New York Times article comes out, says that there's reliable sources, multiple, that were working in the CIA and at the White House that were in briefing rooms that this program had actually started by Bush before Obama took over. Obama was briefed on it when he took office and said, proceed with this to stop Iran's nuclear program. No named sources, so everybody's saying, oh, the US admits it. And now there's a congressional investigation wondering if this was actually an intentional leak by the Obama administration as part of this campaign, the election campaign. So this thing has gotten pretty serious about the intrigue here. And of course, the US also said that Israel was a partner in this program. So it looks now, again, I take it with a grain of salt since we don't have named sources, but it looks pretty convincing that this was the operation everybody suspected it to be. I've got a sample of that I've just fired up here, or I've got ready to fire up. Did I fire it up? Yep. Oh. And what I'm going to do is launch it, and we're going to take just a very quick look at watching it infect my system. And when I do that, we're going to see the techniques that I talked about. Using these techniques and spending a few more hours, literally just 3 hours or so, I was able to, with just the sysinternals tools, to figure out how Stuxnet infected the system, what it was dropping on the system, and then infer the purpose of all the files that it dropped on the system, how it registered itself to stay on the system, all of that with just the sysinternals tools. I've got Stuxnet ready. What? That's not the right one. Did I click on the wrong one? I apologize for that. I thought I clicked on this, apply. So this will take a second. Sorry about that. But what I'm going to do is show you what would have happened if, is it restoring? Hello? No. Oh, I've got 2 VMs running? No? Oh, that's the problem. So maybe this is set up, ready to go. That'd be nice. And actually, let me get this other VM ready while we're doing that so I can show you that quickly too. So here we go. It's all ready to go. This is what's on the USB key. It's actually there's some more stuff on the USB key, and it has slightly different names. This is a malware sample, and what security researchers do is make things convenient to package up and then execute and activate. So this is not actually what you'd look at. In my blog post, there's a blog post series where I go in depth on this with what you're going to see here, where I show you the exact files that this would have. This is the link file here. I called it blah.link. And when I do this move command, this is a Windows XP system with that patch that fixes that vulnerability removed on it. Let me make sure process monitor is watching. It is. And here I go. Let's get that up here, and I'm going to say enter. And what's going to happen is Explorer, when I go refresh, files look like they disappeared. What actually happened is that Stuxnet lifted itself into Explorer and then inserted a user mode rootkit to cause Explorer not to see the files. They're actually still there on the USB key, just being hidden from view. Now, it's going to take about a minute here for Stuxnet to completely infect the system. It's going to launch several processes that are host processes that are legitimate Windows executables, injected remotely malware into them, not using DLL injection, just simply inserting code into them to execute. It's going to drop several files, 5 or 6 files on the disk, including its major payload, which is itself, some of the drivers that we talked about, configuration files, and then it's going to register itself as those drivers to start every time the system boots. So when we come back here in a second, and I've got Process Monitor paused to show you refresh highlighting in action. I'm going to press F5 here in a second. And there we go. These are the new processes created. The thing about these particular processes is that they're legitimate processes. These are the local security authority processes, the exact same as this one. Although anybody that, everybody knows that there's only one LSAS on a system, Windows system, right? So it looks obvious. Everybody knows that. Even my mom knows that. So it's obviously these are bogus LSASs. Now, are they the real ones? Well, if we check the digital signature on them, they are. Well, actually, we're not connected to the internet, so it wasn't able to do that, to check. That's, again, one of the problems with disconnecting from the internet is not being able to get to the servers to validate digital signatures. So the difference, though, is that if you look at the real LSAS, it's hosting some Windows services here, and these are not. Also, if you look at the DLLs loaded into this, well, lots of DLLs, important DLLs for LSAS. And if you look at the bogus ones, very short list of DLLs. Of course, we're not going to see any malware in this list because Stuxnet injects itself as just simply code. Let's go and say category is right and see what it did. Now, the first thing I'm going to do, well, actually, let's get another sounding board here. I'm going to do an F5 in auto runs and see if it dropped anything new. This takes a second because it's trying to connect to the internet. Of course, this machine's not connected to the network, so there's network timeouts happening. And we are going to see some interesting files. In fact, because it's not able to get to the internet too, it thinks these things are legitimate when in fact these are Stuxnet drivers. And where did it get its name Stuxnet? Well, here's the XNet. I don't know where the STU came from, but that's where Stuxnet came from. And if you look, this particular sample is signed with the stolen Realtek certificates. So it's really kind of fascinating, too, if the U.S. is behind it, that they basically authorize the theft of digital signing certificates, really the heart of what right now is trust on the internet, and use them for cyber warfare. It's a pretty big line that we've crossed in that regard. So let's go back and we can search for MRXNet. And here's where it's dropping it right here. And it's dropped from this LSAS process. If we look at the process tree, there's actually more LSASs that launched as part of this operation. In fact, there's 3 that have already terminated, leaving just those 2 that it's working on. But so there's dropping the files, setting up the registry key so that it'll start. That's what Autorun saw. And here it's dropping its major payload right here, OEM7.inf. The interesting thing about this one is if you jump to this location, this directory is where driver installation files are stored with INF and PNF extensions. If you were scanning this directory, would this thing stick out? Because that's malware right there. And there's several other, it's got 3 others that have similar names. Now how hard is it to clean Stuxnet off a system that's been compromised? It's really hard if you don't know how to do this. There, it's done. So it's actually this driver right here that's got the payload in it. So it launches during the boot process, and I've also got in the blog post how it does this, reaches into that OEM 7A and then injects it into services.exe on the next boot. And that's how it revives itself after every boot process. So pretty fascinating piece of malware right there. I do consider that the most sophisticated piece of malware ever created. Not just because of the forward 0 days, but also because of the rootkit that caused the centrifuges to move faster than they were designed to. That's the rootkit. The rootkit part was that the signals that they had the Step 7 controller send back to the Iranians operating the centrifuges, everything under control. Everything operating normally, nothing to see here. And then before you know it, the centrifuges start to blow up. And that's when they realized, and the Iranians they actually put some of the scientists in jail. There's suspicion that they executed somebody for this. I mean, they thought that they were screwing up before they started to figure out, wait a minute, little kind of coincidental that all these things are happening where the signals are coming back okay, and yet they're not. The thing also is that it was discovered accidentally. A Russian antivirus company got a report from one of their customers in Iran. Their server was rebooting. So they go take a look at it, and they find, just trip on it, Stuxnet. They and that's how the story unraveled over about a 2-week period right there in the middle of July 2010. So the next thing, though, is this. How many people have heard of this one? Flame. This one's, people are calling Kaspersky, who's standing right there. He's the head of, Eugene Kaspersky, the head of Kaspersky Labs in Russia, major antivirus company. Their company discovered this one, and he claims that it's the most sophisticated, he believes that it's the most sophisticated piece of malware ever created. I don't believe it. It is a very sophisticated piece of malware, but I'd say Stuxnet's more sophisticated. This is a 20 megabyte package. Flame is a 20 megabyte package. Largest piece of malware ever. And you'd think it was written in .NET. No, I'm just kidding. That was just a joke. No. But it does have an alternate language. Most malware is written in Delphi or C or something like that. And this one is written in Lua, a scripting language commonly used in games. Many games that you play are written in the Lua scripting language, heavily used in this. Very modularized. So it looks like it's made by different teams. Like one team made the Bluetooth detector. One team made the thing that could turn on the video camera and record people. Another one turns on the microphone. So lots of different components. Of course, it came out that a terminal server signing certificate that we've got that used a weak hash, MD5, to sign. They came up with a not seen before cryptoanalysis technique to generate files that would match legitimate hashes, collision attacks on MD5, so that they had the package look like it was signed from Microsoft, and of course, then they used that to create a man in the middle on Windows Update to actually push malware onto people's machines using Windows Update. So lots of very advanced things in this. Now, just yesterday, Kaspersky came out and said that they found evidence that these were the same people that made Stuxnet. There's a module that's in both Stuxnet and this. So if Stuxnet was created by the US government and Israel, Flame was too. Flame was discovered, by the way, circulating in the Middle East also, and also like Stuxnet was primarily in Iran. So looks and also the interesting thing about this one too is that it's been circulating for at least 2 years. Let's pull up Flame. So I've got Flame right here ready to execute. This is also going to take about a minute to launch. This is the primary file right here. I don't have Zoom it running, and I've renamed Process Monitor Procmon1 because Flame is sysinternals aware. So I guess there could be the author of Flame in here in the audience listening to how to defeat sysinternals tools. But that's the primary file, OCX. They picked that extension because many antivirus engines don't even look at OCXs. They say that's not an executable extension, which is, somebody want to say it? Lame? Yeah, I'll say lame, not that word you said. So this is, again, where if they actually had listened to one of my talks, they would have said SigCheck actually knows how to find executables. Actually, the antivirus people, they would have been scanning it properly. So I'm just launching it here. And what's going to happen in a few seconds is that we're going to see files start to appear. And we're going to come back to that. So I don't waste your time waiting for that. And just wrap up here before we come back. So don't get ready, don't go until I finish that. But the trends, malware's becoming more and more sophisticated. It's being used in cyber espionage now, state-sponsored cyber warfare. We've seen clear evidence of that, where you've got people with big money and lots of sophistication creating malware. In fact, it's gotten, and by the way, you notice that a lot of the malware that I showed you still fit those common characteristics I came up with 5 years ago. No icon, packed, no description, no company name. Why? Because they can. Because you can still do it. That's the problem with antivirus. If it doesn't know about you, it's not going to treat you as malware. And you can skip all those things, and most people don't look for the signs like that. So malware can be very successful without bothering with those things. In fact, this article just came out this morning in my MIT Technology Review. The antivirus era is over, and then it goes on to talk about Flame and Stuxnet and the fact that there, one out of every 3 malware samples that people discover and actually know are running around don't, at the time of the discovery, when they run into them, have no antivirus. Okay, let's go back. And has it launched? Now this thing, by the way, this is also kind of skittish. Notice what I had to set the time zone to get this thing to activate. So if that's not suspicious, So category is right. And what we're going to do is, you might have heard that it dumps a SQL Server database, SQL Express database on disk. So malware that uses SQL. That's our first two. There is the SQL database. And it also, more SQL database stuff. It does, you can see that it's dropping stuff here in the WebM repository. And let's see, get rid of that one so we can get a better look. Now, this traces look different every time I look at them. So here is the primary executable that it's dropping, which is sitting in Microsoft shared MS Security Manager, mscrypt.dat. That's one of its support files. And it also drops OCXs on the system that will launch as part of itself. There's one of them. And in fact, if we say, just let's look for create files, we can see them all. So 1, 2, 3, 4. They've got OCX names and sys names. They're actually just vanilla executables disguised with names. They also are not digitally signed. The only thing that was used, that the cert was used for, was to do the man in the middle on Windows Update, not actually to sign this. So these do show up as looking like they're signed from Microsoft. You can see what happens when I try to run Process Explorer is actually here. Well, actually, I need to look at SigCheck on this guy. And that was, I should have grabbed the whole thing, ccalc. And there you can see this one, they didn't even bother putting the publisher information. The other ones do, like that. This net one has publisher information, net teps. And by the way, I just got this sample just a few days ago, so I haven't, with all the tech ed stuff going on, I haven't had time to thoroughly examine it. But we've figured out basically enough to clean this thing off the system, just using the sysinternals tools for a few minutes. And you can see this one is one of those ones pretending to be from Microsoft. And then it also sticks itself in the run key. Oops. Oh, no, sorry. It sticks itself in WinLog authentication What? Oh, yeah, create file. Thank you. Let's just do an R. So it sticks itself in LSAS's logon authentication profile list, so it's going to load as a DLL in LSAS, which is the process that Stuxnet was using. It also was found to use the same kind of zero-day Stuxnet was. It's not clear if it was using it after or before Stuxnet became public, because nobody knows when exactly this thing started to circulate. Now let's authenticate. So while that's doing its search, there it is. Right there. Authentication packages, and there it's, whoop, not that one. I actually got rid of the categories right, so there it is, sticking itself in. You can see that at the bottom right, mssecmanager.ocx, and that's the primary executable. So that is Flame in action, and we, again, with the sysinternals tools, we're able to know enough to get rid of it. So finally, I'm a little bit over here, and I don't know how much because the clock stopped, but there's a book, obviously, I made. I'm not going to bother showing you the video, but you can go to Zero Day the book and see my trailer for it. I'm also going to be at the bookstore tomorrow afternoon, and this book is coming out right here. I'm going to give it away to one person only. Actually, what's a good trivia question?
You are out of time. So
okay, sorry. I need to go. I'm way over, and I'm being rude, so I need to go. All right, so come to the book signing tomorrow, and I'll give it away to some random person. And thank you very much.